This is a quick quiz for fairly advanced maths students. Actually, I'm not sure any of the questions involve much algebra or anything, but I've tried to make ones which are a bit creative, need a bit of thinking, hopefully to give you a bit more of a deeper understanding of maths as you go through. Pause the video to have a go in your own time, and I'm just going to keep going nice and fast. So remember to use pause if you need to thinking time, especially to have a go at them on your own. Right, root 4 is just 2. Root 3, root 2 just cancelled with root 6. 2 times 50 is 100. So the answer is root 1 over root 5. Oh, wait a sec. Square root of 1 is 1. So it's 1 over root 5. This looks awkward. Yeah, I think it probably is awkward. I'm going to spot something, which is this is 10 squared. And this is 10 to the minus 3. Oh, wait a sec. So that means that's 10 to the 2x equals 10 to the minus 3. So I can then, by inspection, observe that the powers have to be the same for the equal sign to be true, because everything else is, because it's already the tens are the same. So 2x must be equal to minus 3. So x equals minus 3 over 2. Let's do the next question. Okay, I'm just going to separate this out into two fractions, which I can do because there's only one thing on the bottom. And then some cancelling happens, which means I end up with 5x plus 1. Solve for x. So I need x on its own, so I'm going to divide both sides by 5. So I end up with 11 over 5y. And I'm just going to put the x equals on the other side just so it looks more normal as an answer. Let's do the next one. Okay, I've been told what the function is. Now I just have to work it out for some examples. Well, that's 10, because that's, well, let's just do that one properly. So that's just 3 squared plus 1, which is 10. I just put a k in. So I look here, oh, there's an x. So I just have to put whatever I can see here in place of the x. So it just becomes k squared plus 1, because k replaces the x. In this case, the k squared replaces the x, which means it's actually k to the 4 plus 1, and using a similar method I end up with 4k squared plus 1 here because the 2k gets squared, and 2k times 2k is 4k squared. Can we ignore brackets if the only signs are plus and minus? This is just a bit of a puzzle. The answer is no, because imagine we just cross these out. You'd have, that would then be 5 minus 3 plus 2, which is 4. But that's wrong, because if the brackets are there, that's got to be 5 minus 5, which equals 0. So let's just be clear, you cannot ignore brackets if the only signs are minus and plus. I'm going to start by trying to get kind of x on its own. So x cubed equals, I'll sling the minus sign over the other side as well, minus 64. So x equals the cubed root of minus 64, which equals minus 4. Make x the subject. Right, there's two x's. I only want one x really. So AR plus 3R. I'm going to multiply everything by R. I'm going to have to get the a's together. So I'm going to sling this over the other side and sling that over the other side. So I end up with AR minus 2A equals 7 minus 3R. And then I'm going to factorise, because the thing is I only want one A. And the only trick I know in maths, method I know in maths for only writing the A once is to factorise. Because then I'm only moving my pen once in the shape that represents an A, which means I can then get it on its own because there's only one of them. Divide both sides by R minus 2, that's the final answer. Yeah, let's do the next one. I like to throw this in. If you're one of my students, you'll recognise this straight away. Oh, we can't just have a minus on its own, so we need to put something there. So I'm just going to put a 1, because a 1 doesn't do anything in a power. It's just like a placeholder saying, oh, I'm here, but you can just ignore me because I didn't do anything. And then minus 1 makes sense, and that's 1 over 7. Whoops, let's just make that 7 look a bit neater. Have a go at calculating these. I've pre-prepared the answers. Pause the video if you need to have a look. but you definitely want to be knowing what all those are. Oh, this is a bit of a notation question. It's a summing question. Right, so the first value is 3, so we need the first value to be 3, and I'm going to make it n squared. And then that works, because n equals 4 is 4 squared is 5, and the last one needs to be 6, so that's the answer there. Oh, what about this? I'm just going to go x squared equals 9, whoops, equals 7 squared minus 3 squared, because I'm getting the numbers over the other side. So x squared equals 49 minus 9, which is 40. So x equals plus or minus the square root of 40. And if you want to do that in terms of surds, you might write as plus or minus 2 root 10. Yeah, or you might write, if you want simplest surd form, plus or minus 2 root 2 root 5. I'm thinking that kind of any of those answers are okay. Penultimate question. Oh, I like this one. Solve x squared is greater than 0. It's an inequality and it's non-linear, which means we have to draw a graph. So I'm going to draw a graph of y equals x squared. I know that's not very neat there, it should be touching. Ah, well that's true for any value of x. So we could say x can be anything. Can't spell. There we go. So that would be my answer. X can be anything. I've just solved it. By the way, related point, I'm always going on with my students about when it's an inequality and it's non-linear, you draw a graph. So this is a good example of where you want to be drawing a graph on autopilot and it makes the question really easy. Many other questions like that where that's the best technique. Okay, or a good technique. Finally, this is the last page, just some really wonky, unusual factorised questions. I'm just going to start answering them. Right, so that's going to have to be root 3x times x, because that would make root 3x, and then plus 1 on each side, and that works if you multiply it out. I basically just worked out what that was, and then on the right hand side, 1 times 1 is 1. That's just going to be x and x, because x times x makes x squared. Oh, and 17 times 8, that's easy. And in the question they helpfully separated it out. Now this one, the first thing to do when factorising is to take out everything that you can that's similar in all the terms. So I can take out x cubed, and then I've got difference of two squares on the right hand side, which is x minus 1, x plus 1. Now this next question is horrible. I'm going to say it's horrible. You can get the x cubed out again, and you have 11x squared minus 7, which means you can always do difference of two squares. You can always do difference of two squares, just sometimes it looks a bit weird. So that'd be root 11x minus root 7 times root 11x plus root 7. And finally, oh look, that would be x. How do we make x squared, x times x? How do we make 2.3? Well, 1 times 2.3? Oh yeah, look, that works. Hopefully there were some useful questions in there to help you with your learning of maths.